Hello everyone, and thank you so much for joining us today. We're here to talk about one of the biggest concerns for anyone managing database workloads has, which is costs. As I've spoken to some of you here today, a lot of you share those concerns, but just a quick raise of hands, how many of you have experienced the pain of watching your licensing bills and cloud bills go up when you need to scale your workloads? Please raise your hand. Yeah, that's most of you. Thank you. As you know, most modern machines come with two processors. One, you have a virtual processor and you have a physical processor. And for every physical processor, you get one virtual processor. And what that, in our research, gives you is about 20% lower CPU utilizations on your machines. However, it comes with a 50% increase in licensing costs. Doesn't sound like a good deal to me. That to you? Not at all. So what we are going to present to you here today is how you can use AWS Optimized CPU feature to reduce your licensing costs by 50% or more, all without impacting your performance. More importantly, when you need to scale your workloads, how can you keep those licensing costs the same or reduce them to a smaller fraction so that you can scale your workloads without having those penalties? So here I'm joined today by Alex, and Alex Zeranin and I work in SQL Server and field. My name is Rafet Ducic, and I'm a specialist solutions architect here at AWS, and I specialize in running cost-effective way SQL Server and Microsoft workloads. Alex, do you want to introduce yourself?
Yes, and my name is Alex Zeranin. I am a principal solution architect at AWS. This is my 7th year with AWS. I am, all those years, was focusing on Microsoft technologies, and these days my primary focus is SQL Server on AWS. How many of you running SQL Server on AWS? Raise hand. Oh, great. I think those who don't run SQL Server on AWS today will decide to do it after our session when you see all the benefits. Thank you.
Thank you, Alex. So let's get started. So today's session focuses on reducing costs for SQL Server deployments. However, you can take these techniques and really apply it to any software licenses where you pay per CPU. What we see is that most customers choose their instances based on the IOPS, the memory, and some of the CPUs that they need. But they actually don't change very frequently the CPU configuration of those instances. When you need to scale your workloads in order to get more IOPS and memories, what customers see is doubling of their licenses because the number of the CPU doubles. And if you understand how our instance sizes are, they're like t-shirt sizes. You go from a large to an extra large, everything doubles. And so it's normal that your CPU double. Well, Optimized CPU feature can help you address these challenges. And today we'll show you how you can achieve that cost savings without sacrificing performance. We will walk you through the cost-saving benefits of using optimized CPU, and also, very important, we will discuss some performance considerations when implementing optimized CPU. So what are some of the challenges that customers see? Well, we know that database workload demand high memory and high disk throughput in order to achieve the required performance. We also know that they depend less on the number of the CPUs, as the bottlenecks that govern those workloads typically are the memory or the disk throughput rather than the CPU. And when customers select the instance sizes based on the memory that they will need or the number of throughput of the disk, those instance sizes come with the default number of CPUs. The way that Microsoft licenses SQL Server is typically per number of CPUs. So this over-provisioning of the CPUs on the instance tends to be over-provisioning in the licensing costs as well. So let's take a look at a typical cost distribution, an average cost distribution for SQL Server running on EC2. So SQL Server on EC2, comparing Standard Edition and Enterprise Edition. So what we see is that Standard Edition accounts for, plus Windows, the software license all in all, accounts for about 35% of the total cost of the instance. While the chart on the right displays the SQL Server Enterprise Edition costs. And in Enterprise Edition, the software cost is a whopping 82% of the total cost of the instance. And again, the higher proportion of the software cost to the hardware cost on the right is because that Enterprise Edition is so much more expensive, as all of you know. Now, let's take a look at the actual dollar amounts that for these instances that we recommend for SQL Server deployments. All of these instances are recommended for SQL Server deployments because they have high memory to the CPU ratio. You get between 8 to 16 gigabytes of RAM per CPU. And so all of these instances are also based on 2 extra large instances, which have 8 CPUs. And what you'll notice from the chart, while the hardware costs is different between instance family because of the availability of features like locally attached storage, different memory, different IOPS, the software cost stays the same because the software cost is based on number of CPUs. So let's say that the SQL Server Standard Edition is about $1,500. Now let's take a look at Enterprise Edition. So due to the higher cost of the Enterprise Edition, the total cost of deployment is so much higher, as well as the proportion between the hardware to the software costs. As we see, the software costs compared to the hardware is 5 times on the total cost of the instance. And this actually presents an opportunity for savings. So how can you address this disparity between the license costs and the hardware costs that we just discussed? Well, this is because the licensing is directly tied to the number of the CPU. Reducing the number of the CPUs will also reduce your license costs. And so that's as easy as saying, well, I could just go to a lower instance. Well, you actually want that memory and those IOPS. Your workloads depend on it, but not necessarily as much on the CPU. So this is where optimized CPU comes into play. First, it allows you to disable hyperthreading, which is that virtual CPU. And just by doing that, you reduce your licensing cost by 50% on the instances. If you've disabled your hyperthreading and you still have additional headroom to disable additional cores, you can do that with optimized CPU. But please keep in mind that SQL Server has a 4-core minimum. So Microsoft licensing requires you to deploy SQL on instances with minimum of 4 cores. So reducing number of CPUs below that will not reduce your licensing costs. So before this reinvent, using optimized CPU was only available to you during instance creation. And so when you create your instance, you had an opportunity to specify number of CPUs. But then, most of you needed to scale your instances up or down, or change the instance family. What that required is for you to create an AMI, to create the disks, or to reattach the disk from that AMI, and then to change the security groups. It was a very involved process. And I assume that a lot of our customers didn't use it for that reason. But just before reInvent, we released a feature where you can now dynamically configure your CPU options on your instances. And I'm here to show you how easy it is to do that. So here we have a R7i instance, which is a an extra large instance. And this instance, by default, has 4 CPUs. So let's take a look and connect to the instance and see what do we see from the operating system on this instance, because that's what's going to direct how many software licenses we need to pay. So here we're using a remote desktop through Fleet Manager, and if you haven't used this tool, it's a great tool which allows you to connect your instances directly without having any additional software right from the console. So we'll log into the instance and we'll open the Task Manager and look at the performance. So we see that this instance has 4 CPUs, as we expect, being that it's an extra large instance, and we have 32 gigabytes of RAM. Now let's take a look and see what does the SQL see on the same instance. So opening the Management Studio, we'll take a look at the CPU configuration. So connecting to that instance, we'll execute a system store procedure to query the number of processors defined on the instance. And so, as we expect, we have 4 processors on this instance. Now, let's say that you have a case where you need to scale your workloads, be it that it's a Cyber Monday, be it that it's an event that is happening and you need additional memory, faster CPUs, more disk throughput. So what we'll do is we'll scale up the instance to the next size up. So we'll go to the changing of instance type after we stop the instance, and right now we're running on a extra large. So the next size up would be a 2 extra large. So we'll be going from 2 cores and 4 vCPUs to 8 cores to 4 cores and 8 vCPUs. But here is the trick. Specifying a CPU options, I can disable hyperthreading, meaning that I can specify 1 thread per core. And on those 4 cores, I will end up with 4 active CPUs on this instance. So this is great. Now, you can change this setting by when you scale your instance, or you can change it directly on the instance by going to the Change CPU options. And here are the same view as we had before, but without changing the size of the instance. So you can just change it directly. Now, let's start this instance and we'll connect to it, and again have the same view that we did before of the operating. What does the operating system see? So connecting to this instance, again, we'll open the Task Manager and look at the performance. And we see that we have 4 virtual processors, just like we did before. But look at this. We have 64 gigabytes of RAM versus 32 before, which means that we have the same view. And again, looking through from the SQL Server standpoint, so just to make sure that this is not something that is on the Windows side. So again, executing the same system store procedure of getting the processors. we still see that we have 4 CPUs, just like we did before. So you were just able to scale your SQL Server without affecting the number of licenses that you need to bring for the server. Okay. So to talk about performance testing, Alex, would you take us through it?
Sure.
Thank you.
Thank you, Rafet. That was fantastic demo. So, okay, fine. We can use optimized CPU. We can reduce the number of processors. But does it affect performance? Can we reduce number of processors without adversely affecting performance? Because we are doing all this stuff like upgrading our instance or selecting a larger instance to get performance. To answer this question, the only way we can do it is by showing you and showing ourselves as well some performance testing. And only that will be a proof whether optimized CPU does or does not adversely affect performance. We cannot we cannot run performance tests using your specific workloads, so we had to resort to some synthetic benchmarking tool. And we selected HammerDB, which is an industry standard benchmarking tool for all type of databases. HammerDB report performance in 2 metrics. It can be new orders per minute, which is universal metric that allows us to compare different databases like SQL Server to Postgres or to MySQL, or it can report it in transactions per minute. And we selected transactions per minute because it's easier to understand and also because we will be comparing only SQL Server to SQL Server. HammerDB also support 2 types of workloads, OLTP and OLAP workload. We selected to run our tests using OLTP type workload because that's what majority of our customers use on AWS. Now that we selected our basic parameters, we need to talk about some specific configuration for HammerDB. And one of them is the database size. In HammerDB terminology, database size is measured in warehouses, with each warehouse allocating roughly 100 megabytes of database space. So how we should choose the size of the database? I mean, it's a dream of every DBA to have database fully fit in memory, but it wouldn't be a practical solution. So our goal was to set the database sizes in such a way that they will exceed the available amount of memory by a significant margin. We built 2 databases for our testing. One with 80,000 warehouses that generated about 8 terabyte database of 8 terabyte size for testing the larger instances. And the second database, 35,000 warehouses, again, about 3.5 terabyte to test smaller instances. In both cases, the database size significantly exceeds the available amount of memory. And finally, we need to talk about virtual users. What are the virtual users? Those are the parallel processes that submit workload to the database. The more virtual users run in parallel, the more load is put on the database. And from the general observation, when you increase the number of virtual users, the performance transactions per minute produced by the database grows up to a certain level. When the growth kind of levels up stabilize, and that means that you reach the top performance that this system can provide. If you increase number of virtual users beyond that point, your performance typically will start dropping because latency will grow, you will overload the system. The change in performance when we change the number of virtual users usually changes very slowly. So on the charts, we usually use logarithmic scale for virtual users. Now with this introduction past us, let's see at some of the results. For our first test, we use one of the best instances for SQL Server, R6 IDN 32 extra large. This instance provides 1 terabyte of RAM, and what is important, it's one of the best performing instances in terms of storage access. It offers 400,000 IOPS to the storage. And on this chart, we present results of 2 tests. The green line represents results, transactions per minute, achieved on the native instance. All virtual CPUs enabled. And then we disabled hyperthreading. So you see the number of CPUs dropped from 128 to 64. What happened with performance? Nothing. No changes. I had to scale up this chart to significant scale so that we can draw 2 lines. Otherwise, they would really collide and they will be indistinguishable. So let's look at the details, specific details for this test. So we went from 128 CPUs, including hyperthreading, to 64. Our CPU utilization did grow because naturally, if you have less CPUs, you have more workload for each CPU. But there is no changes in transactions per minute. Practically no changes. The small discrepancy that you can see have a percentage point relates to the fact that HammerDB is really a statistical tool. So typically, you expect 1 to 2% difference between experiments. Okay, so it works fine for the largest instance. Let's see what will happen when we scale down and we take the mid-tier instance into consideration. So we went from R6 IDN 32 extra large to 16 extra large. So it's exactly half of the previous instance, half amount of RAM. So we went from 1 terabyte to 500 gigabyte, half of the number of CPUs, and half of the throughput, storage throughput. So because it's a smaller instance, we use the smaller database, 35,000 warehouses. And obviously, it reached saturation at a lower number of virtual users. But again, we see the same scenario. You disable hyperthreading, no change to the performance, to the instance performance. And here are the same results in a tabular form, just to easier to review them. So what we concluded with this, that disabling hyperthreading for R6 IDN didn't affect performance. But will it be the same for other instance types? Maybe they will react differently to CPU optimization. AWS offers a significant amount of instance families. And within each family, we have multiple sizes, altogether over 450 different instances. we obviously were not able to test all of them. So what we did, we applied some criteria. First, we selected instances that are recommended for SQL Server workloads, and those are memory optimized, those that give more memory per CPU. Second, we selected out of those instances, we selected those that offer highest level of IOPS for respective family, because, as we mentioned, IOPS is very important for SQL Server performance. And finally, we decided to limit it to only latest generation of the instances. And that resulted in 4 new families that we added to our testing scenario. And within each of those families, we selected the largest and mid-tier instance. So that, and for each one of those, we have to do 2 experiments, 2 tests, one on default configuration and one with disabling hyperthreading. So that created 4, 8, 16 additional tests. And those 4 tests that we did with R6 IDN brought us to really representative number of instances. As you may notice from this table, that all of these instances offer a significant level of IOPS, less than R6 IDN, but still meaningful. However, all of them offer more RAM than R6 IDN. So if you think that your workload may benefit, the structure of your workload is such that it will benefit from more memory, those are the instance families that you should consider. Okay, the results. Again, we see the same scenario. We disable hyperthreading, and these are the results for the largest instance in each family. We disable hyperthreading, we do not see change in performance. There is one case there where performance is like over 100%. That, again, that same situation, that each test is statistical and we expect variation up to 1 to 2%. It does not mean that disabling hyperthreading increased performance. It just stayed at the same level. One of the things that I would like to bring your attention to is that CPU utilization appears to be highest for R6 IDN. And why is that? Because that instance offers the largest amount of IOPS, 400,000 versus close to like 250 to 60,000 for other instances. So the CPU has to work harder to catch up with the capacity of the input-output system. Okay. Next, we did the same tests with the mid-tier instances. And again, we see exactly the same scenario. What I would like to bring your attention to, that for this set of tests, we also included the R7A family. And it's based on AMD processors. And R7A does not offer hyperthreading. So what you have are all the cores. So what we did in this case, instead of disabling hyperthreading, we disabled half of the cores. And it still showed the same performance. So encouraged by these results, we decided to test how far can we push optimized CPU? What can we do? Where is that limit? And we focused on R7A so that we take hyperthreading out of the picture. And what we did, we gradually decreased number of cores we decreased it by 75%. We went from 192 to 48 cores for the largest instance, and from 96 to 24 for the mid-tier instance. And we didn't see any change in performance. We stopped at that point because CPU reached kind of 85–90%. So we understand that if we start cutting cores more, we will become CPU bound, and that will stop. But it's so exciting that for typical OLTP SQL Server workload, you can reduce the number of CPUs by 75% and cut your license cost by 75% without any detrimental effect for performance. And on that note, it brings us to further discussion of specifics of the cost, how this all affect the cost. And I will pass the button to Rafet.
Thank you very much, Alex. So now that we've seen that disabling hyperthreading or disabling cores doesn't affect performance, let's look at and see what does this do in terms of cost savings. So here is the same chart as we had before of the SQL Server Standard Edition. And each of the bars here represent a total cost of the instance unoptimized. So the SQL Server cost is, let's say, around $1,500. What we are showing in the light pink area is the cost savings by using optimized CPU on your BYOL cost for a SQL Server. So say that the cost of the Standard Edition is about $700 for those 8 CPUs. By using this optimized CPU, you're able to save 50%, or bringing that cost down to $350. In turn, you're reducing the total cost of your instance between 27% and 16%, depending on the instances types. So let's take a look and see what does this do to the Enterprise Edition. Because the Enterprise Edition is so much more expensive, the cost is, or the opportunity for saving is so much greater. And now we see that the cost savings range between 39 to 30%. And just like disabling hyperthreading with Standard Edition, we're able to save Enterprise Edition costs. Before implementation of this feature, you only used to be able to do this with Enterprise Edition on physical core machines, like you had an ESX host or you have a dedicated host, and you're able to license all of the cores on that machine. And then you would put your SQL Server workloads on it and try to pack it as tightly as possible in order to take advantage of that. With this, you no longer have to do that. You don't have to worry about, oh, I need to take this big box and I need to make sure I fully utilize it. You can use it in Standard Edition. You can use it on Enterprise Edition. You can use it in shared tenancy, in default tenancy for your SQL Server. So let's take a look at and see, in that demo we were showing the scaling event. So here we have a SQL Server running on a 2 extra large instance. And the cost of that instance is $2,800. Now you have an event which causes you to scale. Either you have some performance degradation because you have a higher number of users, or you have anticipating higher load on your instance. So what do? You upsize that instance to 4 extra large. And now you get double the memory, double the RAM, but also double of the CPU. So the total cost of the instance goes to $5,600. And given everything that we've said, my question is, does it have to? No, it doesn't. Using optimized CPU, to disable hyperthreading or half of the cores, we can bring the total costs back down. So you're going to pay the same for your hardware and for your Windows, but the cost of your SQL, which is the biggest ticket item, stays the same. So now the total cost of the instance is at $3,400. So I hope that you can see the value of this, and especially as you are scaling your workloads to a higher instance sizes. So let's talk about some of the best practices when scaling your workloads. As we have seen, using optimized CPU results in about 35% total cost reduction and a 50% reduction in SQL Server licensing without negatively impacting your costs. Remember that the SQL Server has a 4-core minimum, so don't disable your cores below that, otherwise you won't receive any benefit from it. And also we saw that because we're now reducing the total cost of instances, the cost to serve is also reduced. So the cost per your transaction goes down. You can control the cost of the licenses, which is the most crucial part, when scaling your workloads by evaluating. Maybe you don't go tomorrow and disable the hyperthreading on all your cores. But when you are needing to scale anyway, look at disabling hyperthreading and what is it going to do for your performance, for your licensing. And really importantly, implement load testing. In our scenarios, because we don't work with your data, we have to use some synthetic workload test, and we used HammerDB, which proved to be really great. But if you have load test tools on your own, implement those. If you don't have load test tool, one of the things that we found useful is transactional replay. You can take your production traffic by capturing the transactions that are going through in the transaction log, and then replay those in your non-production environment to try to simulate the load and see how does your environment perform under that. If you have, let's say, always on, you have your primary and the secondary, you can implement this feature on your secondary side, fail over, and then see what the impact is, and easily reverse those changes without any needs to recreate instances or anything like that. All you can do is go into the console and change the CPU configuration. So Alex and I have been working on this research, really not to sell you anything, to try to enable you to save the costs, to try to tell the story that this is one of the things that we find in our research, in our working with our customers, and we wrote a couple of blogs regarding this. One is the optimized best practices for optimized CPU. Alex, you were primary on that. Do you want to tell us about it?
Yeah, it actually gives you much more testing scenarios, much more charts and diagrams, and you can look at specific details how the performance changes, and we also include much more examples of disabling cores on top of disabling hyperthreading for multiple instance families.
Great. And also, another blog is, if you want to take out your phone, you can scan the QR codes, is about how you can retain your optimized CPU configuration when you need to scale your workloads. It talks about some of the examples that we showed today. So we wanted to take some time to address your questions. So we're going to end the presentation and talk to you in person. But I really wanted to thank you so much for coming and for attending this session. Here are contact details. Your survey and your opinion is very important to us. So please take time to fill out a survey, and we will talk with you just in a moment. Thank you so much.
For us to be able to provide you with more details, we need to have a good CSAT score. So that's obvious.
Thank you.
Thank you.